Hello. So for our statistics project, we will be talking about the correlationship between suicide rate and income level slash GDP, which is gross domestic product, from 2010 to 2011.
Hi, I'm Huda Almayali.
I'm Allan Kimmel.
I'm Eren Okandan.
I'm Priscilla Saldana.
And I'm Maynaire Wang.
So pretty much just the goal of why we really chose this specific data set was because the five of us were all, when we were talking, we were all just really interested in mental health issues going on around the world. And we were really just interested in seeing if there was some sort of connection between both lower income countries, violent death, and in general, mental health. So we pretty much hypothesized and thought that people who lived in countries with lower income or gross domestic product, aka GDP, will be way more affected by both violent death and mental health issues compared to many other countries and many more other people in more abundant or richer countries. So we all know that mental health is a very big concern in today's modern age, especially with children, adolescents, and teenagers. And even though we know it is a concern ourselves, we believe it's not really brought to light in countries where their culture isn't comfortable or really doesn't talk about these types of things. So we chose this initial data set just because we thought it was a good and diverse representation of all the inequalities of mental health going on around the world and globally. So mental health has pretty much affected like tens of millions of so many people around the world annually. And we were hoping that by understanding the demographic of some countries, we'll be able to see the correlation between mental illness and their income level. And we just really wanted to help raise awareness for better healthcare in lower income countries, just so we can see and learn from that as well. Especially with the pandemic that literally just hit, it has impacted so many people all around the world mentally and financially as well. And all of the mental health issues have pretty much just soared and inclined so much. And since we know that there's so many, there's a lack of access to just mental health services in general. And we realize that's probably because of costs and income level and stuff like that. So we were hoping by using this data, we can see the correlation between everything and enhance the quality of the services, mental health services, so it can be accessed by more people around the world. So pretty much the summary or background of our initial data set was it has a correlative link between both homicide / suicide rate and the GDP, which is, like I said, gross domestic product. And this specific data has 8 variables in every country over a 50-year period. But once you see throughout this slide, you'll see that we're only going over 2 years, which is 2010 to 2011, just so we can determine correlation and change over those specific years and see if there is a set income or and/or GDP correlating to said region or country. So our 8 variables of interest are going to be countries, region, and year, but obviously only 2 years. And we'll also be looking at variables of homicide rate and suicide rate, just because those 2 variables are big extremities of why there is a specific mental health decline in those specific regions or countries. We will also be looking at the GDP, which is gross domestic product, and income level, just because those 2 are very similar. Well, not similar, but they just go hand in hand together. So it would be great to see the correlation between all of it.
Yeah, for our first data cleaning, what we did was, what we noticed was our columns names didn't make much sense and they didn't look good. So our initial goal was to make sure that all of our columns names were good. As can be seen on the left side, which is our initial data set, none of the columns were capitalized. Also, dots were used between words, which kind of looked ugly when we did our graphs, which is why we made sure that instead of using dots between words, we used underscore, and we also made sure that every word, first letter of every word was capitalized. What we can also see is that ISO 3C and ISO 2C columns, which don't really make much sense, but what they are essentially is just abbreviations for different countries. For instance, AFG is Afghanistan and AF is also Afghanistan. So they were just kind of repetitive columns, which is why I deleted ISO 2C and renamed ISO 3C as country code, which is what it is. Also, we had admin region, which is just region by itself, where the country is located in the world. So after we sorted through our columns, then we deleted countries that didn't have a million population list, just because of the fact that our intentional homicide rates, suicide mortality rates are per 100,000 people. So we wanted to use only countries that had more than a million population. In our initial data set, we had more than 170 countries, which included small island nations, which had less than 50,000 or less than 100,000 population. So we deleted those countries that didn't have a million population. And then after we sorted through a population requirement, then we made sure that every country had an associated region, just because of the fact that we also wanted to look at different regions and compare between them. For instance, how does Europe compare to North America? How does Europe compare to South Asia? Or how does Middle East compare to Africa? None of the European countries had an associated region. For instance, France, Portugal, Spain, UK, Germany, none of them had an associated region. So we just made sure that they were in the region that they belonged to. Also, some of the regions were separated into two, which included high middle income, low middle income. For instance, Japan was South Asia, high middle income, and then another South Asian country was low middle income, even though they all belonged in the South Asia region. So we just made sure that we had the correct regions. In the end, we had 8 regions. After we sorted through all these steps, we had more than 10,000 observations, which had NA values in them. So our next step was to remove all the columns that didn't have NA values. So we just didn't want to put in random values, which would affect our results. So if Afghanistan didn't have a data from 1985, then we deleted that column. And then we looked through our data set for the most common year, and then we found out that 2010 and 2011 was the most common year for our countries. But some of the data set had, for instance, Azerbaijan had data from 2010, but didn't have data from 2011. Since we wanted to focus on those 2 years, if a country didn't have one of the two, then we deleted that column as well. Also, our suicide rate and intentional homicide rates had 7 digits, which kind of looked ugly when we did our graphs or when we did our summary tables. So we rounded off all the digits to 1 digit, essentially. These are our summaries and table. For intentional homicide, our median was 2.5 per 100,000 people. Our mean was 7.5 per 100,000 people. Our suicide rate was, for median, we had 8.6 per 100,000 people, and our mean was 11.77 per 100,000 people. So when we look at our frequency table for region, we had 33 observations from Africa, 40 from Asia, 2 from Australia, 76 from Europe, 2 and 8 from Middle East, 4 from North America, 44 from South America, and 16 from South Asia. When we look at our income levels, we had the most data set for high income with 92. We had low income with 20, lower middle income with 62, and 69 for upper middle income. And when we look at our two-way table for income level per region, it can be clearly seen that low income and lower middle income was most common in Africa, and high income and upper middle income was the highest in Europe. This was our initial data set, which is what it looked like when we downloaded our data set and put it in R. As it can be seen, we had lots of NA values and our regions weren't set. Some of the countries had aggregate region, even though they should have had an associated region with them, or they were just left blank. So which is why with our data cleaning process, our final data set looked much cleaner, which is the final result. It can be seen that we didn't have any NA values and all the countries had an associated region with them. And it can also seen that it looks much cleaner overall when you look at the columns and the rows.
Okay, so for data visualization and graphs are a great way to see how variables relate to each other. And for these graphs, we use ggplot2 as our package. And we use the rcolor brewer package for all these wonderful colors and palettes. So first we have the bar graph, which is income level based on region, both categorical variables. So we use palette set 1 for this graph. We also, on the x-axis, we can see that it's tilted at a 90-degree angle, which is for the reader's enjoyment and just to make it visually better. We can see from the graph, it goes on the x-axis, it goes from high, low, lower middle, and upper middle income. We can see that Europe has the highest income, while Africa has the lowest income, and it's there again on lower middle income, and upper middle income has South America as the highest. Next, we have our histogram. It's perfect for numerical variables, which is suicide mortality and GDP per capita. We can see that this histogram is skewed to the right, which shows that as GDP per capita decreases, suicide mortality increases. This does not ensure that it's not set guarantee. It's just how these variables interact with each other. So it's not really guaranteed that if you have a high or if you have a low GDP per capita, there's going to be a really high suicide mortality. For the bins, which is important, we square root the number of observations, which gave us 15, and we use 15 bins. We also have the max at 80 for suicide rate. Next, we have box plots. It's for numeric and categorical. And these side-by-side box plots depict a relationship between suicide mortality and income level. We can see that low income and lower middle income have nearly the same median, while lower middle income has the highest range and the highest outlier at 80 once again. And we can see that low income has the lowest range, so barely any range for that. And that's pretty much it for the box plots.
So in our next graph, you can see that it is a scatter plot. A scatter plot is great for comparing two numerical variables. On the x-axis, we can see the GDP per capita and see that it goes all the way up to about 100,000. Suicide mortality is on the y-axis, and you can see it goes up by 20% increments with the 10% half increment indication. Our plot, you can see that there is not a lot in the top right corner, and so it has a general downwards to the right slope, a negative slope. And so you see that the GDP per capita decreases as suicide mortality increases, or inversely, as GDP per capita increases, suicide mortality decreases. Okay, and our next one is a bubble plot, which again is great for comparing two numerical values, but with the added categorical value, which in this case would be regions. We can see that Africa has a very high mortality rate, in comparison to other regions. And again, it is exactly like reading a scatter plot in that the downward to the right slope is the same. And for our last one is a word cloud, and it is great for comparing categorical variables. But in this case, the largest countries are the ones with the highest suicide rate. So most notable among them is Lesotho. Notable for this, you will see 2 of each country because we are looking at 2 separate years. So it's 1 for each year. So notable is, again, Lesotho, Eswatini, and Lithuania, Belarus, just lots of big names in there.
All right, so now we're going to be talking about regression. So the first regression graph we're going to be talking about is our linear regression graph. And for our explanatory variable, we use GDP per capita. And our response variable that goes along with this explanatory variable is going to be suicide mortality. And so the first interpretation that our group wants to talk about is the intercept interpretation. And so that would be that if we set GDP per capita to a value of 0, suicide mortality would be predicted to be 11.63. And then for our slope interpretation, we said that with an incremental increase in GDP per capita, it would lead to approximately a 0.00001452 increase in suicide mortality. Another really important statistic is our R-squared value statistic, which basically tells the predictive accuracy of this model. And we found that with using the linear regression model for suicide mortality, the accuracy of this model would be approximately 0.0879% of the time in predicting this response variable. All right, so for logistic regression, in order for this graph to work, we would have to first convert this response variable into a bicategorical variable. And so the way we did that was we turned suicide mortality into, if the value is greater than 5, R would automatically set it to high. And if suicide mortality was any value other than greater than 5, it would automatically be set as low. And so with that information, we used the explanatory variable GDP per capita and intentional homicide. And here our intercept interpretation was if GDP per capita and intentional homicide were both 0, then suicide mortality would be negative 0.9586. And then our slope interpretation was holding intentional homicide constant, an incremental increase in GDP per capita would lead to a 0.99997 decrease in the odds of suicide mortality. And then our other slope interpretation was if GDP per capita is constant, the incremental increase in intentional homicide would lead to a decrease in 0.97118 odds of suicide mortality. And these are all exponentiated values. All right, so now we have our classification. And the way we did this, as explained in class, was we set our variable values. So our explanatory variables that we used here were 3 variables. We used GDP per capita, suicide mortality, and intentional homicide. And the values that we assigned it were 6,005 and 7.33 respectively. And then we used the final model R code to basically tell us that our data was going to be based off of the 9 nearest neighbors. So our model name is called the 9 nearest neighbor model, and it classified this data point as a lower middle income data point. All right, here are references. Thank you for listening.